Probably like 5. Did I already tell the Mitcha thing? I don't know if I told this class or my advisor. But yeah, so if you type in my name to an old computer, it can't say it right. So the closest it got is Mitcha. So that's where that came from. All right, but welcome back. I hope you guys had a fantastic break and few days off, and some of you caught up because you were texting me over break or asking me, hey, is this on Schoology or whatever? A couple things weren't on Schoology. So great work if that was one of you that got caught up and stuff. Eli, you good, man? Are there none in the jar? Go in the corner. Eli, to your right, in the corner. There's a plastic thing. Nope, keep going all the way to the corner. All the way to the corner. Plastic thing, bottom drawer. Get like a handful. Put them in the jar if you would, please, sir. All right, so just to brag for a moment, this is my niece. She is in the USC Marching Band, and we actually were able to get some tickets way up in the nosebleed section because, you know, anything closer is more expensive. But this is one of the things I got to do, as well as driving a total of 18 hours, I think, because it was like 8.5 down and 9.5 back up. So yeah, that was in South Carolina. So made a quick trip south. But this is what we want to do now that we're switching back into school mode, right? As fun as break was, we're time to switch into school mode. But again, we all make mistakes. The plan I had written on the homework board ain't our plan anymore. Because I forgot, tomorrow we are math testing. We're doing it, not my choice. Not my choice. What that means is you don't have math class. So instead of having math class and homework, you just show up, take your growth test, show what you know. It's not a big deal. And we move on with life. So you guys will be math testing tomorrow morning. So all that to say, make sure you bring your Chromebook. Make sure it is charged, or you're going to be fighting the fight of how many extension cords do we actually have. Because we'll do all of Block 1, Math and Connections, because Mr. Estes and I are blocked. We're going to have everyone over here taking the math test in the morning, and then Block 3, they'll take it in the afternoon. So you guys get to take tomorrow morning. No new math homework tomorrow, so that shifts our plan. But 423 can still be due on Wednesday. Okay, so double check what's due on Wednesday. 412, 421, 422, and 423. So now on your 422, let's go ahead and label our axes like this. So we're going to bold in up. Guys, you never just want to leave like what picture is there. Just leave like, if you had graph paper, you would have to draw axes on it. So even though I gave you a like snip out of graph paper, we need to like make the axes bolder. And we're going to label them. But guys, what I have written in pencil, you do not need to write that. That's just me counting out. There were 17 boxes and 23 boxes. I'm going to need to kind of use that information as we start to scale our axes. I would not scale your axes yet. I would not put points on here yet. I would just draw the axes, label them, and then we're going to work on filling in this table. And this is the big question that was asked to you when you came in, is for 1 centimeter. Because could we measure bigger than that? Yes. Did I bring enough pennies? No. So every group has plenty of pennies to get 1 centimeter, but that's what you want to try to figure out first. Now you might not actually have to measure them if your brain is turned on and you're really paying attention to what's been given to you. But I'm going to give you guys 3 minutes to try to figure this out. So what you want to try to do is fill in this entire table. What you want to try to do is fill in this entire table. Go for it. I know we're in new groups, but we should be talking and working together.
Okay, Jeremy.
Ooh, I need your cards back.
Okay, so.
Hey, can people help Sam and Sophie remember they sit over here? Because I'm probably going to forget.
Yep, we'll put all that duty on Carolina. It'll be Carolina.
Don't put duty on your friend.
Nope, it's Carolina. It's her job.
She said they're going to put all that duty. Wasn't your card here?
Oh.
Bro.
I want to put actual duty on Carolina.
Jane never gets called like the next month. Finally figure out when he stole the card. What was your card? Yes, you did.
Okay, so if the height of the tower is 4, and then the number of pennies, then if we just divide it, then we can find out that if we just use these two, then we can just figure out the numbers. I don't know how we would divide it. Would just be like 28
stacked up. Like, stack the pennies like this. Like, you're not trying to stand up end to end. Like, stack the pennies like this. Yes, I take them. To make a quick, easy reference. So if you're stacking pennies flat.
How many does it take to equal? Yeah, it's 7.
How many does it take to equal 1 centimeter?
Does look like it's gonna be 7.
This is going to be tough because I moved all of you, and now passing out papers is going to be confusing all of you.
I didn't move.
Well, so I made the groups, and then I tried to kind of keep some of you relatively where you like to be. Because like, if people like you near the back of the room, as long as you're focused and like doing stuff with us, that's fine. I don't care.
There's no way that's what.
Emery already dropped her backpack, so I had to default to her being over here.
I love my spot here.
Claimed her spot with her backpack before I did this. How tall would 0 pennies be? Yeah, 0 pennies would be 0.
I think it is. That one kid that checks out the dates of the pennies.
I mean, they can't all be
We're
the
not
same.
second.
I don't guarantee that they are all different, but they can't all be the same.
Hudson, how much change do you have?
I've had this cup of quarters here for like years, because I know it's enough for this activity. Those quarters live in this cup in my drawer.
Don't you mean pennies?
Yes,
Hannah
pennies.
Schaefer to the Phoenix or to the Perry office, please. Hannah
I have
Schaefer
a
to the
quarter
Perry
right
office. Thank you.
Oh, it is
Couple
7.
of quarters. I don't know, maybe 10 things.
7? Yeah, well, 15. 70, yeah. So don't you just use 7? Oh, I just chose that. I failed.
Are you helping?
I already did it.
No, but are you? Is that noise helping anything? No.
Okay, so 63 divided by 7, I think, right? Is that what we need to do?
All right. Random cards. I know y'all missed that. You've been heartbroken not getting randomly called on. Jack, can you help me with our table over here? And actually, I guess I can do this at the board.
Kinda.
Kind of. All right. Hey, bring it back together, friends. I did what I said. I gave you more than 3 minutes because I had to pass stuff out. Jack, what'd you guys do?
We did. To find the value of the first penny. Wait, no, the first centimeter. We did 4 divided by 28. Wait.
Yep, that's what we did.
Now wait, why'd you do that?
Because it's the only one that has both of the values.
Yeah, guys, your table gave you the answer, kinda. They gave you that 4 centimeters is 28 pennies, which is probably more pennies than what you have at your table. But they tell us that is that, right? 28 pennies is 4 centimeters. 4 centimeters is 28 pennies. So what Jack said they noticed is across here, there's a relationship. And would you be looking for a relationship based on addition? No, that'd be silly. Add 24 pennies to 4 centimeters. Add centimeters with pennies. Those aren't like terms. So we look for the relationship through multiplication. Now you said this backwards, but I'm going to guess because I heard the other numbers that you guys were saying. We set up 28 divided by 4, and what do we get? 7. So that tells us 7 pennies per centimeter. Questions there about the fact that this relationship across, we figured out, is a times 7 relationship. Times 7. Is this going to be white as an option? Oh, it learned!
What?
It got smarter. Now it's giving me white as an option instead of just both black. So if it's 7 for 1 centimeter, how? I should have brought my card.
Wait, but we can still answer that, right?
Still answer what? Yeah, and Emery, your card is next, because apparently my shuffle wasn't that good. So what about the next one for 15 centimeters?
105.
How'd you figure that out?
I took 7 and I times it by 15, even though they're different.
This is always times 7.
Yep.
So Emery got, sorry, again?
105.
10. Ah, crap. What now if I gotta go this direction? Ashley, what if I gotta go this way? Divide by? Ooh, it's always 7, right? This was times 7 across. Opposite direction. Opposite operation. Divide by 7. What do we get there?
9.
9. Lane, to go across here, what do we do? Yeah, because times 7 going that way, right? Devin, right here. Nope. Sophia, our 12 centimeters. Oh, you know 12 times 7.
84.
I was about to say, do the 10, then do the 2.
Yeah, well, my rate taught that sword today.
So if we call the number of centimeters x, you're going to need to add this on your paper. If we call the number of centimeters x and the number of pennies y, we can always say y is, Raiden, what could we say y is always? 7 what? So we can say y is always 7 times the number of pennies. Or, since the number of pennies is x, y is always 7x.
Wait.
So if the number of pennies is x, something we don't know yet. So like, what if you had $1? How many pennies are in $1? 100. Help. So wait, 100 pennies, would that go on the left or the right? Ooh. Crap, so we said y is equal to 7x. What could I say about x is equal to the y value divided by 7? Because that's what we did right here. We took the y divided by 7. That's how we found our centimeter. So if you had 100 pennies, $1, how tall would that be? No. If we have number of pennies, that's our right column. To go from right to left, we said that has to be division, because we're going the opposite direction. What's 100 divided by 7? It's going to be a decimal, I think. What'd you get? 14. So a little over, like, because this keeps going, a little over 14 centimeters. Right, if you had 100 pennies, which I think we're close over here. So, alright guys, let's graph this now. But let's be smart about graphing it. Would going by, like, 5s be a nice choice? Watch, okay. Let's look at one axis at a time. How high would we like to graph for our height of tower? Do we want to go like 5 centimeters, 10 centimeters, 100 centimeters? I mean, with the data they gave us. So if we want to get to 5, let's just say if we want to get to 5, we want 5 to be somewhere out here. So we probably don't want to go 1, 2, 3, 4, 5 because then we barely use any of our graph.
I'd say we go back 2.
Like 2 boxes equals 1?
Yeah.
So don't write this yet, but let's play with that. 1, 2, 3, 4, 5. Ooh, I still only use like half my graph. How many boxes could we make equal to 1? Let's do 4 boxes equal to 1. So let's try and see how much we use if we go 1, 2, 3, at 4 boxes. Blue, actually. Yeah, so now I think we all can probably agree on this. We'll make 1 centimeter. 2. Yeah, that's okay. Have a little bit of leftover space. We use most of the graph, right? Most of the grid space. And at 5 centimeters, how many pennies do I need? Well, at 5, okay, let's put at 5 centimeters. So if we know 5 centimeters, that goes here. How do I figure out the height it will be? Sorry, or not the height, the number of pennies I need. My bad, 5 centimeters. How do I figure out number of pennies? Times it by 7. What's 5 times? So we need to get to 35 up here. I only have 17 boxes. Ooh, I need to get to a bigger number than I have boxes. Think about that for a second. Play with it like in your head or try it on your paper. How do we need to scale that axis? Or think about what number would work really nicely. Like, what pattern did we recognize? You can. You're allowed to scale however you want. Yeah, so when you're asking can we, this is why I love math, guys. You can do whatever you want as long as you follow like a couple rules after that. Now hold on, before you start writing that. So let's think about that. Lane said, could we do every one box? Hold on. Don't write this. Do not write this. Lane said every one box is 2. If we do that, what's 2 times the 17 boxes we have? 34. Do we get quite where we want to? So Lane could instead do 3. Or hold on though.
Let's just do it by 7.
Aren't we using 7s over here? Like, if I scale by 7... Now wait, why do I want to do 1 box is equal to 7?
Yeah.
Instead, I could do Donna. Yeah! So forget about that 3. Let's go 2 boxes is 7. Now write this down. So then another 2 boxes and we'll be at... And then go ahead and keep going.
7, 14,
21.
I was like 24.
28.
Wait, what?
So we got there kind of quick, but that's okay. We're not going to use this upper part of the graph, but like it's okay. We fit on here, right? So I'm going to do this up here to make sure that our friends playing along at home can see this. So if every 2 is 7. Now let's plot our points. 1 centimeter was 7 boxes. 2 centimeters.
Wait, but if we do number by penny and we count by 7, we don't even get to like 84.
It's okay. We don't have to graph all of this data.
Oh! Well, oh man, I still beforehand. It just looked weird if it had a gap.
Like, you could graph this whole table, but we know this table is showing us a consistent pattern. Wait a minute. 3. What do you notice about these points?
Let me guess, they're like increasing by a certain number every time.
These points, if I connect them together,
Make a straight line.
wow, look at this.
Oh, man.
I placed one of my points in the wrong spot. And look, everything after it was wrong. You make one mistake and your whole graph goes skew right here. I goofed this up, guys. You make one mistake and then keep like going off of that mistake. It's not good. So this is always why I encourage you to do math in pencil. I just counted up too many boxes by accident. I did, but good thing I could erase.
Wait, Bethany, you're in here? Yeah. You don't sit next to me, I just...
So now they're in a straight line. And where's our straight line quote unquote start at? What's the better name for that? What's the name for that?
Zariel.
The what? The origin, meaning, what is this graph showing us? Say it louder. Proportional, and this is kind of why I wanted to leave the top of this open. This is a proportional relationship. Yeah, like literally, you can just write it on the graph because we got the space. Sure. Remember, guys, this is for you. So Raiden, quit playing with the pennies and write down proportional relationship. And then please put the pennies back in the cup because we need to move on. That's why I stopped you, right? But I was hoping before you. Hey, try to keep them from falling on the ground, or if they fall, like pick them up because I need these this afternoon. And if we lose too many, it's not going to work. Nice. Was it face up? Isn't it? It's supposed to be face up for some reason. I don't really believe in superstitions. I am like afraid of the dark kind of.
I thought a superstition like
It's just like a. It's, yeah. It's just,
that is a normal.
you just
thing to
don't
be
know
afraid of
what's
the dark.
in the dark, right? That's what freaks me out. You just don't know. So,
That's what happens when you watch too many Marvels.
to review.
And Scream.
Hey, to review, and you can write this down if you want. The two things we said this graph had that made it proportional. This line is straight. It goes up the same every time, right? On our graph, it was kind of going up 2 over 4, up 2 over 4, up 2 over 4. It's a nice pattern. Straight line, and it started where? Origin. So if you want to make the note on your paper, straight line and 0, 0. Right? That's what makes a proportional relationship. Straight line, 0, 0. If you are struggling with any of our proportions work in Schoology, I've now dropped one video. I'll probably drop more. Math Antics is like a little, some of you might feel like, oh, this is like a little childish. Not real. I mean, he like makes it really clear, and I can't show too much because it's not my video. But he has really good examples here of what are proportions, how do we solve them. So yeah, if you're struggling, pizzas! Yeah, he starts talking about pizzas. So if you're struggling with proportions, go check that out.
Wait, what do you mean you can't show too much of it?
Because it's not my content.
It'd be copyright.
I mean, I don't know if it's quite copyright, but it is something I don't own. If you did not get 423 from the back, get 423 from the back. And y'all are smart. You can read. Start reading through this with your partner. Highlight whatever you want if you think there's important information in the problem. And start chatting to try to fill in that table. Oh, sorry. The graph shows it, but the hole punch worked against me. This is 420 miles, not just 20 miles. That would be sad if it was just 20 miles. So you might want to write, like, over here. He can drive 420 miles with a full tank of 12 gallons. Yes, I know you'll burn more gas when you're... Hey, Raiden, can you put the pennies away? We're moving on and we have an activity to do. I have not enough time left, and I'm struggling that I'm having to correct your behavior. I gave you directions about reading the problems, trying to fill in the rest of this table, and you're ignoring them. Let's reset. We're talking on average.
Wait, are we
So
doing-
yes, I know you'll use more gas when you hammer down the gas pedal. You'll use less gas when you're, just cruising, not putting a lot of gas. We're talking on average, so we're going to say that this is a proportional relationship. Because when people talk about cars, they normally talk miles per gallon, right? Like, and they don't really care about, well, if you're driving this fast or if you're driving this slow. Start talking with your teammates about how can we fill in that table.
Okay. Do you want to read it and then we can talk about it? Well, and you can start and I'll read. That's you.
If you have zero gas, probably not
Oh, there is a
going.
backup.
We're saying 0, 0. You're right. There's a reserve tank, but if you're literally out of gas, which I got nervous about
Is
yesterday.
this 0 gallons?
No, if that's empty too, like 0 is empty, empty, empty.
You just times that by
No, they connect
Gallons.
together. When you fill your normal tank, it fills in your reserve.
Oh, so then
Never trust your reserve tank. Do not drive with your empty light on. You'll end up running out and be sad.
How much is in your reserve tank?
Not much. It's like a gallon. I mean, different cars are different. So, like, a pickup truck might have a bigger reserve because it's going to need more gas if you get down to the reserve tank. So you guys said with 0 gallons, how far are we going?
0.
Sweet. We all agree on that. Keep going.
Okay, so 12. So then 3. Full tank.
Sorry.
42. So all we have to do is do what we did last time. So that's
I
42.
don't believe this. Because I think if you take 12 and divide it by 420.
No, I meant to do 420 divided by 12.
Okay, well, first we gotta do 420.
I'm actually buying these on Amazon for like $12. They were better than me.
Let me see if we can get through that. Like, let's talk at the end of class, right? Not in the middle of a problem. So, Matt, what did you do? What division, what math did you set up to help you work with this table?
20 divided by 12. Isn't that for all?
So, Matt did miles per gallon. Whether you realized it or not, when you set up division, you're making a per statement. When we set up 420 miles in like 4 or 12 gallons, we do division. This answers per. 35 miles per gallon. Pretty good. Although hybrids these days are way better. This was written a few years ago. So, okay, 35 miles per gallon. Bethany, how can I figure out then if I have 3 gallons, how far I can go? Quit whispering, it just distracts people. Guys, when you try to like help somebody answer, it's actually rude. Give them time. Give their brain a moment. Especially with random cards, when a teacher calls and you by surprise, it's like, ah, okay, let me figure it out. All right, so Bethany, we're going down this way. Is the miles bigger or is the gallons bigger? The miles is definitely bigger. So when we're going down this way, are we multiplying or dividing? Multiplying. We want to get our bigger number. We want to get how many miles. And we said we can go on 1 gallon. We can go 35 miles. You might want to add that somewhere. It'd be convenient for us to add that into the table. So with 3 gallons, okay, we are triple. So if every gallon is 35, 35 times 3, 105. Now here's another fun thing. How does 3 get to 6? Times 2. So if we know that's times 2, this also is times 2. Because it's proportional. Proportional relationships work really well. Whatever direction you can draw an arrow and figure out multiplication, the other one does that too. So we could do times 35, or you could just do times 2. Right? You get to pick. That's why proportional relationships are so nice. You can decide how you want to solve it. Whatever the bottom does, the top does. Whatever the top does, the bottom does. Whatever the left does, the right does. So if I do this times 35, this is also times 35. Like, it works really nicely. And if we graph it, straight line through 0, 0. Right? You don't need to graph this, but if we did, straight line through the origin. Questions? I think I'm out of time. Oh, don't sell. No, I have 4 more minutes. Or just celebrate. All right, so let's check.
Celebrated.
Real quick, if you're at the grocery store and you see these different pricings. I'm curious if you guys can then figure out what a whole pound of each different cheese type would cost. Take 2 minutes to try it, and then we'll do 2 minutes to go over it.
Well, this is half. And then this is half.
These are different cheeses. Right? Different situations. Different cheeses. But you know that zero cheese is $0. Sorry, right beneath the problem we just did. How much would zero cheese cost? So this is proportional. Yeah. Jane, if we know 3/4 of a starting with A. So I mean, Jane, you're gonna help me with B. But guys, I think most of us know to go from a half pound to a whole pound, we got to double, right? If what you're given is half, to get to the whole pound, you got to double it, and that would get us $8.40. So I'm going to skip to C because that's what I actually started writing down first, and we were limited on time. So, Jane, if you know what 3/4 of a pound would cost, could you figure out what 1/4 of a pound costs? How could I go from 3/4 to 1/4? Divide by what? So if we divide by 3 on the right, we also divide by 3 on the left, and how much would a 1/4 pound cost? $2. How would I go from Eli? How would I go? No, you're not here today. How'd your card cycle? Devin. Eli is here. My bad. I'm mixing up who's not here. Eli, how do I go from 1/4 to 4/4? Ooh, now, so we did division, but now I can multiply. And if I multiply on the right, I multiply on the left. Or you could have said 3/4 and another 1/4, but that's not really using the proportion. So this is using the proportion here. And we get $8. Man, this grocery trip is getting expensive. If we know how much 2/3 is, could we figure out 1/3? Say it louder. I don't know who said it. Sophia,
What?
say it louder.
$2.25.
Ooh, what was the 1/3?
75 cents.
Yeah, if you had 2/3, Sophia figured out every 1/3 is 75 cents. And if we triple that to get 3/3 of a pound, because bananas are not that expensive, how much is that?
$2.25.
That's actually more expensive than they probably even are. Yeah, bananas are fairly not expensive.
75 cents?
Not a banana. We're talking pounds. If you have 5/6, how can I get to 1/6?
$7.50 divided by 5.
Yeah, if I know the 750 for 5/6, to get from 5/6 to 1/6, we divide by 5. And now I'm definitely out of time, so we gotta call it. Have a wonderful day. Homework is due when this week? Wednesday. And nothing's due Friday, because I won't be here. Homework's due Wednesday this week.